Okay, so welcome back to lecture once again, guys. Now in this lecture, I'll be talking about a Hadoop architecture, but by telling you a story in a layman way. I'll try to explain you each and every component so that you all will be able to remember it, so that you all will be able to give an answer when someone is going to ask you a question inside your interview or maybe in general. And above all, so when you will try to execute any kind of a job, maybe a Spark job, maybe a Hive job, maybe a HBase kind of a job, maybe a MapReduce job, or whenever you will try to perform any kind of a read and write operation, you will be able to investigate into your job. You will be able to understand that what is happening on a lower level. So this is how I'm going to give you the explanation about entire Hadoop ecosystem in a complete layman way. So don't worry, leave it up to me and just try to watch this entire lecture, and for sure you all will be able to understand a Hadoop architecture, that how it is going to work, by the way. So let me share my screen, and I believe my screen is visible to all of you. And let's start talking about HDFS, Hadoop Distributed File System architecture, or precisely I would say Hadoop architecture. Yeah. So let's try to understand that how Hadoop architecture is going to actually work. So see guys, Hadoop actually works as a master slave architecture. So basically, if I'll talk about a Apache Hadoop framework, or I will say Hadoop framework, so it is basically a distributed storage and a processing unit. Now, what is the meaning of this distributed storage and a processing unit? How actually it runs a job, how actually it is going to store a data, how it is going to achieve a fault tolerance, how it is going to, or what is even a meaning of a fault tolerance, by the way, how it is going to maintain a replica, or how it is going to work on a commodity hardware. Commodity hardware means a cheap one, right? So which can crash at any point of a time. So how it is going to work and how it will be able to process a massive amount of data. So this is something that you all will be able to understand with the help of Hadoop architecture. So see guys, like I said that Hadoop architecture always try to follow a master slave kind of a architecture. Now, so master will be doing its own job and slave will be doing its own job. It try to follow a core principle that write once and read as many times as possible. So this is the core model, core philosophy Hadoop is going to follow. But everything we'll try to understand, so as we will progress inside this particular lecture. So first of all, let me introduce two major component inside this Hadoop architecture, or HDFS file system architecture, Hadoop Distributed File System architecture, right? So the very first component that you will get to know inside a Hadoop architecture is called as NameNode. Yeah, NameNode, or you can say this one as a master, and it will be having some sort of a roles and responsibility. And the second kind of a component that you all are going to observe is called as basically a data node. So let me draw 4 data node over here. Yeah, so data node. So let's suppose we have a data node 1, we have a data node 2, we have a data node 3, and we have a data node 4. Yeah. Now, what this name node is going to do, or what this data node is going to perform. So what is the roles and responsibility of a name node? What is the roles and responsibility of a data node? Let's try to understand that particular part. And then eventually I'll be talking about basically a Euron resource manager as well. So a lot of things will come into picture. A secondary name node comes into a picture. Name node with high availability will come into a picture. Zookeeper, I'll try to introduce you. So each and everything I'll try to introduce one by one, component by component, so that as a story you will be able to consume this entire Hadoop architecture. Lecture may be going to be a lengthy, but yeah, so once you are going to understand it, once you will be able to understand, believe me, for an entire life it will be with you, and it is going to help you out not just in big data but in many other places as well, because in many other places nowadays we are following a similar kind of architecture. Yeah, so name node we have, and we have 4 data node: data node 1, data node 2, data node 3, data node 4. Okay, fine. Now, what is the roles and responsibility of a name node? What is the roles and responsibility of a data node? All of these 4 data nodes that we have. So let me try to explain you with the help of one simple example. Yeah, one simple example. So let's suppose I have a file over here, right? So let's suppose I have a file over here and file name is, let's suppose, text.txt. This is a file I have. And size of this particular file that I have written over here is, let's suppose, 300 MB. Yeah. So 300 megabyte of file I have over here. Someone has given me this file. Yeah. And they are asking me that, can you please try to write it down or like store this particular file in this distributed system? Yes, in this particular distributed system. So how it is going to happen with respect to a NameNode data node. And this is how we will try to understand our roles and responsibility of a NameNode and a data node. So someone has given me a file of size what? So file of size 300 MB. Fine. Okay. Maybe 1 GB, but yeah, I'm going to show you all the calculation with respect to 300 MB. Okay, that's cool. So someone has given me this 300 MB of file and someone is asking me that, okay, write this file down into your system, right? And in my system, so let's suppose I have this computer. Let's imagine that as a computer, one single computer, although I can configure all of these things in a single computer itself. But let's suppose this is my computer number 1. This is my computer number 2. This is my computer number 3. This is my computer number 4. This is my computer number 5. Just in a layman way. Yeah. So all of these computers are basically connected. How? So basically in this manner, so NameNode, let's suppose, is connected to all of these computers in this manner. So as you can see that these computers are not connected. There is no connection between like these computers in between, or I'm saying that DataNode 1, DataNode 2, DataNode 3, DataNode 4. But all of these computers are connected to a computer number 1. Kind of in this like a topology, or in this manner, it is connected to each other. Now someone is asking me that try to write down this 300 MB of a file. Okay, 300 MB of a file. So Hadoop distributed file system, right? So what it will do? So it will try to distribute this particular file into a different data node, or maybe into a different computer. It will try to distribute it. As of now, let's imagine in this way. Yeah. So basically, whenever you will try to give any kind of a file to a Hadoop system, so it will try to break down these file into a small chunk, basically. Yeah, in a small chunk, so that read operation or write operation will be efficient. So if I'm trying to read a big chunk of the file, it is painful because it is going to consume more RAM or main memory, you can say, and more CPU, a compute. But here, so Hadoop follows a basic principle that, okay, first of all, I'll try to break down this particular file, the file that is given to me, into a small chunk. Now, what will be the size of that chunk? So initially, the Hadoop initial version, so over there, so we have a configuration, we can configure it basically, but in an initial version, so it was 64 MB of a chunk that Hadoop system was trying to create for whatever file you are going to give. In a later stage, the modern Hadoop, if I'm going to talk about, so here, because now there is a Hadoop 3.x which is running in a market. So here, basically, the block size, it is going to like break down this particular file into a small chunk. And here, we call that as a block size. So in a latest version of Hadoop, in a latest version of Hadoop, you will be able to find out that block size is 120, my bad once again. So block size is technically 128 megabytes. So one block will be having 128 megabyte, means if I'm giving 300 MB of file, so it is going to break it down in 128. As simple as that, right? So if I have 300 MB of file, so if I'm going to break it down, so I will be having a block 1 of size 128 MB, right? I will be having again a block 2 size 128 MB, right? And then remaining data, so block 3, yeah, block 3. So what will be the size? 44 MB. So if you are going to add it up, it will become what? It will become 300 MB. So I have given this 300 MB of file. Now, the very first thing it will do is it will try to break it down into a chunks, or technically into a blocks. It is trying to break it down in this particular manner. So 128 and a 44 MB. Now, technically I have 3 blocks. So, and like I told you, so why it is trying to break down into a blocks? Because if I'm going to write sometime 1 GB of file, sometime 5 TB of file, sometime maybe a KB of file, it will be very, very difficult in terms of doing a read and write operation and allocating a equivalent amount of the resources to do that operation. So that is the reason. So what it will do, it will try to basically break it down into a blocks. Okay, that's great. So it is trying to break it down into a blocks, one by one, one by one, one by one. It is trying to break it down. Now, once it will be able to break down, it will try to take a block number 1. Yeah, it will try to take what? It will try to take basically a block number 1. And then it will try to perform a write operation for block number 1. Not for 2, not for 3 as of now. Let's just try to focus on block 1 of size 128 MB, which is a part of same file, the file which I have passed basically, this test.txt file which I have passed. So it will try to basically like store this particular file. So how this storage is going to happen by the way? So it will try to request, right? It will try to request to whom? It will try to request to a NameNode, saying that okay, I wanted to store this file, and obviously it has broken down this entire file into a 128 MB. Now NameNode is going to check. NameNode is going to perform some sort of a check. Now, what kind of a check it is going to perform? So the very first check NameNode is going to perform, that if file already exists. If file already exists, so in that case, it is not going to store the same file. As simple as that. Yeah. Then second one, if you are trying to hit a system, so whether you have a permission or not, you have permission or not. Yeah. So it will try to check for basically a permission. And then a third part. So if it is going to perform this to check that, okay, file doesn't exist. This is a new file which I'm trying to store in a particular location, because I'm going to give a location, right, that store this file into this particular directory, and that directory can exist inside my entire ecosystem, entire my Hadoop distributed file system. So once it will be able to perform this check, so it is going to return a list of the block location. So NameNode is going to return what? So NameNode is going to return this third number point. And what is this third number point? So list of the block, list of block basically means block number 1, block number 2, block number 3, that okay, this is the size of block number 1, this is the size of block number 2, and this is the size of a block number 3. And we have a multiple slaves, we have a multiple data node. So NameNode is not going to store. NameNode is a master. It controls everything. It commands everything, but it is not going to store your actual data. It is going to store a meta information, which I will talk in a later stage. So after some time, so I'm going to discuss about that part as well. So it is going to return a list of the block, for example, block number 1, block number 2, block number 3. And it is going to locate, or it is going to even send a location of a data node. Data node. So in which data node you can store a block number 1, in which data node you can store a block number 2, and in which data node you can try to store a block number 3. Now here comes another problem, right? That it is going to return a list of the block and a data node, but we are talking about a distributed computation, right? We are talking about the distributed computation. Not just that. So we are also talking about a distributed computation with a commodity hardware. Now, what is the meaning of commodity hardware? A cheap hardware, right? Not a very expensive one, not a very dedicated one. A cheap hardware we are talking about means that can go down, that can crash at any point of a time, right? Or maybe we are talking about a data center across a world in a different region of the world. Let's suppose we are talking about that kind of a situation. Now here, so if I'm storing some file, just a hypothesis, right? Just a hypothesis that if I'm trying to store a file into a data node 1, for example, a block 1 I'm trying to store into a data node 1, and if this data node will crash, if this will go down, right? If this will go down, then what? Yeah, then what? That is a reason, right? That is a reason. So it is going to store a data, but by default, so it will try to even replicate the same data across a different system. And that is called as replication factor. Replication replication factor. So by default, so you can again try to configure these things. You can try to make it 3, you can try to make it 13 or whatever you want. That's completely fine. But by default, replication factor will be equal to 3. What is the meaning of it? Meaning is very simple. That if I'm trying to store one single block, let's suppose a block number 1, if I'm trying to store a block number 1, so I will try to create a 3 replica of block number 1 across a different data node. It's a computer, right? It's a computer by default. Just like imagine that you have a laptop. You have basically 5 laptops. You have connected with each other in one laptop. NameNode is working, and other laptop you have named it as a DataNode 1, 2, 3, and 4. Yeah. So replication factor is equals to 3. Fine. Replication factor is equals to 3. It simply means that it will try to store the block number 1 in 3 different data nodes, so that even one will go down. Even one will go down at any point of a time. I have 2 replica, right? I have 2 replica, and I will be able to create a backup immediately. We'll talk about that. Like we'll talk about that story more and more going forward. But yeah. So replication factor. So technically, it returns a list of the blocks and a data node, basically pipeline. Data node pipeline. It try to return. What is the meaning of this data node pipeline? So whenever I'm trying to store some sort of information, right? So whenever I'm trying to store like this particular part of the information, so maybe my name node has returned that, okay, first try to go to a data node 2, then try to go to a data node 3, and then try to go to a data node 1. Data node 1. So this is the pipeline my name node is going to return, because just for block number 1, just focus on only one single block. I'm not trying to store the whole 300 MB of the data. I'm just talking about a block number 1 over here. Nothing much, just a block number 1. Fine. Just try to focus on block number 1. So it has returned a pipeline saying that okay, so you can try to store it into a data node number 2, data node number 3, data node number 1. Okay, that's cool. So if it has returned, so now this very first block, right? This very first block will go inside a data node 2, right? So very first block, so block 1 will go inside a data node 2, and here, so block BLK 1, so block 1 will be stored. As simple as that, block 1 will be stored over here. Now, once it will try to store, once it will be able to store this first copy, so block 1, first copy, fine, first copy, first replica, right? Now, so what was the pipeline? Data node 3. So now go to a data node 3. Now it will be a roles and responsibility, right? So of this block 1, we have stored inside a data node 2. So it's a roles and responsibility of data node 2 to forward this block, because we have a pipeline, right? So data node 3 saying that okay, so I have stored 1 copy. Now you have to store a block 1 second copy. Fine. Now third one is what? Data node 1. So now it's a responsibility of data node 3 to store this one into a data node 1. So block 1 copy number 3. So all of these 3 is been stored. Now it will try to send a feedback to this one, block data node 3, that okay, I have stored. Then this will send a feedback to this one. This will send a feedback to this one, and this will send, right? This will send a feedback, or you can say acknowledgement, to finally a name node saying that okay, right? So after successfully writing this 3 copy into a data node 2, copy number 1, data node 3, copy number 2, data node 1, copy number 3. So after storing this 3 copy of only block, I'm just talking about block number 1, only this 128 MB of a data. So once it will be able to store this one, so it will try to reply back that okay, so basically it will try to send a ACK, acknowledgement. Yeah, ACK, acknowledgement, it will try to send, saying that okay, I'm able to store it, and same thing will go to my client. So let's suppose my client has given me this file, right? This particular file. So it will try to send back a feedback to the client saying that okay, I'm able to store all of these information into these particular node. So 3 replica I'm able to create. So this is how block 1 write operation will be done. Now same will happen for block number 2, and same will happen for block number 3. As simple as that, right? So for all of this block, whether it's a block number 1, block number 2, or block number 3, so one by one, it is going to follow the exact same process, this exact same process. And once it will be able to store the whole data, then I can say that my 300 MB of a data is been stored inside my HDFS system. So hope this is making sense to all of us, that how data write operation happens inside this HDFS system. Now here, right? So here, if you are going to observe, right? So here, if you are going to observe, so we are not storing any kind of information. We are not storing any kind of a data inside a NameNode. NameNode is trying to do what? So NameNode is going to receive the acknowledgement, and it is going to receive the ID of the block, the meta information, because we have stored like a block 1 into 3 places, again block 2 into 3 places, block 3 into 3 places, right? So NameNode is going to store a meta information. NameNode is going to store what? NameNode is going to store technically a meta information. Fine. NameNode is going to store a meta information over here, and technically that meta information is nothing but a block ID. Yes, technically it's basically a block ID, that okay, for this data I have like divided this data into this particular chunk, and now this chunk goes into this particular data node. So ultimately my data node is, which is technically a slave basically here, now it is going to do an actual task, it is going to do an actual work, and it is going to store the final data set. So here, to store this 300 MB of a data, 300 MB of a data, so we are trying to create a 3 replica. So in total we are occupying 900 MB of a hard disk space. Simple, yeah. If I'm going to change a replication factor, so obviously the storage requirement is going to change. It is not going to be same at all. Yeah, it is not going to be same at all. So fine here. So let's try to write it down. So block number 1. So we are able to store into a data node 2, and then data node 3, and then data node 1. Now block 2 we are trying to store, let's suppose, into a data node 1, and then data node 2, and then data node 3. I'm just assuming it. There is no hard and fast rule for this one. Then block number 3, which is having a 44 MB in size. So data node 4, let's suppose, data node 1, and then data node 2. So in this way, I'm trying to store a 3 replica of block 1, 3 replica of block 2, 3 replica of a block 3, and successfully I will be able to store this. Successfully I will be able to store it, and after storing it, obviously I'm going to return an ID. Yeah. So I'm going to store, and then that ID will be available inside a NameNode. Yep. So this one and this, all of these operations are going to happen not one by one. So it is going to happen in parallel. Why I'm saying in parallel? Because when we have created this 3 block, so NameNode is going to understand that, okay, we have this particular task and we have a multiple nodes which is available. It will start sending one by one, parallelly. It will start engaging all of these nodes. It will not wait for a completion of one block and then it will write second block, then it will write third block. So technically it is going to do all of these operations in parallel. Yeah, it is going to perform all of these operations in parallel. Now, one more thing, right? One more thing. So here I'm saying that NameNode is going to store a meta information. Yeah, this is what I'm trying to say as of now. No, it's not correct. Yes, it does store a meta information. I do agree with it, right? But it will not store a meta information directly. Means it will not try to take an update of this block ID directly. Now what it will do and why it will not be able to take that meta information directly? A reason is very simple. NameNode is a first interface or first point of contact, a POC, a point of contact, right? So point of contact for any kind of a job you are going to submit. Maybe a read operation, maybe a write operation, but yeah. So whatever you are going to do inside your entire cluster, NameNode is a master. So technically NameNode is a very busy entity or very busy person, right? Now, we are trying to write and we are trying to perform a read operation millions of times, right? Millions of times. So if it will keep on taking or keep on storing a block ID directly, its bandwidth will be choked. and it is going to take a time, right? It is going to take a time and it will become slow. So what people have suggested that what if instead of updating an ID or this meta information directly to a name node, what if we can try to do the same operation in some different system and then on a timely manner. So when we'll be having enough meta information, not like one single update, but when we'll be having a update in a bulk, we will try to send it to the name node, and then name node will try to take a multiple update in a bulk. And this is where, right, this is where in this entire ecosystem, secondary name node comes into a picture. So many beginners thinks that secondary name node is an alternative of a name node into this entire distributed system. But again, that's not true. Secondary name node, it looks like name wise that, okay, so whenever name node will go down, maybe like a secondary name node will try to take a charge, but no, it's not going to happen in that way. Secondary name node has been configured, it's been written, so programmatically it's been designed in such a way that it is not going to take a backup, or it is not going to work on behalf of name node, but secondary name node has been designed for a specific purpose called as checkpointing. Now, what is the meaning of this checkpointing? CKPT. Checkpointing. Now, what is the meaning of this checkpointing? So I told you that whenever we are going to store one block, right? So we are trying to store a multiple blocks. We had actually one data out of that 3 blocks, and out of that, so we are trying to store 9 times, right? 9 times. So maybe 9 times we have to update, we have to acknowledge, and there will be a failure because of some like an unwanted situation. So we can't come to a name node again and again and again because it will be a very, very busy person, right? So keeping that in a mind, so people have suggested that, okay, so let's try to create a secondary name node. So where we will try to update a meta information. We will try to update what? We will try to update a meta information. How? Right? How? So inside a secondary name node, you will be able to see a 2 entity. So one entity is basically FSIMAGE, file system image. Its full form is basically file system image. Yeah. And then there will be something called as edit log. Yeah. So there are 2 entities which exist inside this secondary name node. Now, what is the meaning of this file system image, and what is the meaning of this edit log? Again, so let me give you a simple explanation for this one so that you all will be able to understand, right? You all will be able to understand FS image and edit log. So see, we have a lot of updates, right? We have to do a lot of updates, acknowledgement based on the acknowledgement that we are receiving on each and every operation. And this is a very frequent update. So let's imagine that I'm trying to do some update at time t. Yeah, at time t. So till time t, or t is equal to 0. So we have some information available inside my data node. Means we have some files which I have stored as a block inside this data node. So this file system image will be having that information, I mean that meta information, that okay fine, so in this data node I have stored this particular block. Now for this particular block, so I have a replica in this data node, something like this. All of this information, all of this meta information will be available till time t is equal to 0. Yes, till time t is equal to 0. Okay. Now after time t0, so if I'm trying to store some sort of information, if I'm trying to do something, right? So all of these, that is something called as transactional log. Yeah, transactional log. So means whatever transaction which is happening inside my entire distributed system, so that will come inside a edit log, a transactional one, right? Transactional one. And basically what happens is that edit logs will be merged. So let's suppose from time t0, we have all the information inside this particular file. Yeah, just consider that as a file, a simple file, right? So till time t0, we have all the information inside this particular file. Now after time t0, t0 till time t10 for this 10 seconds. Let's measure that in a second. Millisecond also you can measure, that's completely fine, up to you, but I'm just giving you like one scale. So time t is equal to 0th second till 10th second, whatever transactions happens, whatever information exchange or whatever like a metadata that system is able to generate, that will come inside a edit log. That will come inside where? That will come inside the edit log. And then it will be merged periodically. It will be merged means the information till time t0 and then information from t0 till 10. Yeah. And it will try to create a new FS image. Let's name it as t10 till time 10. So this is having an information. Now this operation, this merging, right? So merging this one plus this one is called as checkpointing. Checkpointing. Now this merger depends upon different rules. So we can try to configure that, okay, on this particular time interval, merge it. So it will merge it based on that particular time interval. Or you can say that, okay, so based on this size, so when edit log will be having like this much of size, then try to merge it. Ideally 64 MB we try to consider, right? So based on the time duration or based on the, so based on the time duration and based on the size. So if file size is going to exceed this much, then try to call the merger and then try to create a file system images. So based on that, it will try to perform, or it will try to like create a new file system images, and it will be having all the information, the previous one as well as the new meta information which we have created between this time. Now this file system image will be having all the capability to answer all of those questions that has happened between this particular time or till this time, right? Till this particular time. And this operation is called as checkpointing. Okay. And this, all of this happens inside a system called as secondary name node. So hope all of you are able to understand that what is a roles and responsibility of a secondary name node. Okay. So here I'm able to create this file system image, right? Create the file system images. Now my name node is not having any idea that what has happened between this interval, right? My name node is not having, because I have not updated anything into name node, right? And name node always works based on file system image. So whenever you will try to spin your machine for the very first time, right? I'll show you, I'll show you that particular part. Yeah. So whenever you will try to spin your like a machine for the very first time, you will be able to see that it loads a file system image first, because that is the whole that gives a whole capability, right? This is how NameNode will understand that, okay, fine. So where is what is like available and where it is available. So what and where answer NameNode, which is my technically a master, will be able to get from where? From this file system image, right? From this file system image. This is like something which is going to happen, right? Okay. So how this file system image will be updated, by the way, how this file system image will be updated, because this behaves like a memory for my name node, right? If this file system image is not available, how my name node is going to respond back? So let's suppose I have a name node, right? I have a name node. So name node is having a file system image till time t0. Yeah, this old one. So old one it is having, fine. Now, so this secondary name node will keep on pinging that, okay, are you available? Are you available? Are you available? And once it will keep on pinging continuously, it will keep on pinging to a name node. So this is my what? This is my name node, a master node, right? So it will keep on pinging, and once it will be able to receive a acknowledgement that, okay, yes, I am available, right? Immediately it will try to update my name node with a file system image till time t0, for example. So immediately, and it will try to delete the previous one, fine. So now in this way, my system is trying to update with my new or latest file system image, and now it will be having a latest meta information. That is the reason I told you that every time it will not come to this name node and then it will try to, update this meta information. Yes, my name node is going to work on a metadata because that's a core capability. Otherwise, it will not be able to work. It will not be able to control the entire cluster, right? But here, right? So now it will be having a file system image, and once it will be having a file system image, it will be able to work. It will be able to work in an amazing way, right? It will be able to work and it will be able to respond you back. It will be able to give you all the detail that which data is available where, which block is available where, each and everything, it will be able to handle it. So this is where this secondary name node comes into a picture, and this is something called as checkpointing. Yeah, checkpointing. Fine. So hope all of you are able to understand that what is the actual meaning of a checkpointing inside my Hadoop ecosystem. Okay, that's cool. So this is the roles and responsibility of secondary name node. Secondary name node is not going to behave as a backup of a name node. Now, next question you are going to ask me for sure, that what if, right? So what if my name node is going down? See, if my data node is going down, that's completely fine. So it will keep on receiving, it will keep on sending a heartbeat, right? It will keep on sending the heartbeat, and if it will stop receiving a heartbeat, it simply means that this data node is down. And if this data node is down, so my name node is already aware about from its file system images, means technically a metadata, that okay, what was the data which was available in this node and where is the backup? Yeah, where is the backup? So it will start replicating it. It will start replicating it, right? So that it will be able to maintain replication factor is equal to 3, because this is something that it has to do. So based on the heartbeat, obviously it will keep on maintaining a 3 replica all the time, right? 3 replica it will keep on maintaining. Now the question arises over here, that what if my name node will go down? Now what will happen? Yeah. So as per the initial architecture, so if name node will be down at that point of a time, so manually people used to spawn the new machine, and then they are going to transfer a latest file system image, FS image, into that name node, and it takes time. So till that time, so your entire cluster will be available only in a read only mode. You will not be able to execute anything new. Now, so people have suggested that okay, to avoid this manual intervention, right? To avoid this manual intervention, what we can do? So we can try to introduce something called as high availability HA standby name node. So high availability standby name node, and how it is going to work, by the way? Yes, so how it is going to work, by the way? So there will be 2 name nodes. So one is, let's suppose, like a active name node. So where I will be having like a FS image, and there will be an alternate which is called as high availability standby name node, not a secondary one, it's a standby. Yeah, so please make sure I'm not writing as like a secondary over here, and don't get confused. Many people gets confused. So let's suppose, right? So let's suppose if my name node is going to be down. So here we have an active name node and high availability name node, and both we are going to connect with a state manager, you can say, called as Zookeeper. So there is a service we try to configure over here called as Zookeeper. Yeah. So whenever this name node will be down, this will go down, right? So Zookeeper will be aware about it, because Zookeeper is basically a state or session manager. So Zookeeper will get to know immediately in a fraction of a second that, okay, so my name node is down technically, right? Name node is down. So immediately it will try to switch the entire name node to a high availability name node. And because at the end of the day, it requires a latest FS image, right? FS image. So based on the NFS or based on the general name node, so it is going to push all of those FS images immediately. So this is nothing but a Zookeeper, as its name suggests. So it is just trying to keep a track of each and every services over here. So if my name node service is going to be down, it is going to spawn this machine, and it is going to say that, okay, fine. So now it's your responsibility to behave like a name node, and this happens automatically. So there was a manual approach, and now this is technically called as a automatic approach. And in this way, it will be able to handle a failover of a name node, which is one of the major component inside your entire Hadoop ecosystem or Hadoop distributed file system. So we are able to understand that how we are storing a data, what is the meaning of a name node, what is the meaning of a data node, what is a meaning of a secondary name node, what is the meaning of a checkpointing, what is the meaning of an active name node, what is the meaning of a high availability name node. So now we are able to understand multiple things with respect to this one. Now, so there is another component which I would like to talk about, which is called as basically yarn. So let's try to talk about another component called as yarn. So YARN. Now what is this yarn? So the full form of yarn is yet another resource negotiator. Yeah. So yarn is basically called as yet another resource negotiator. What is the meaning of this, by the way? So see, whenever we are trying to execute something inside our cluster, so where we have one name node and then we have a multiple data nodes. So this is called as cluster, right? Combination of this 5 component is technically called as cluster. So whenever we'll try to do some sort of a operation, or whenever we'll try to perform some sort of a data processing, for example, so we are trying to do some sort of a data processing, right? We are going to do some sort of a data processing over here. So data processing, and to do a data processing, so we can try to use a different kind of a engine. So one very popular engine is basically a Spark nowadays. Yeah. The previous one was, or initial one was a MapReduce, and even Hive. Likewise, we have a multiple data processing engine. So what we do, so we try to send a code, and data is already available across all of my data node. So we try to send a code, right? We try to send a code over there, and then it will try to execute a code inside all of these data node. So in between, by default, yarn comes into a picture. So yarn comes into a picture. So let's suppose I'm trying to process my file, and over there, so I'm trying to, maybe I have written a code inside the Spark, which is going to do some sort of a prediction based on my data, which is going to build some sort of a model, or maybe a prediction it is going to do, or maybe I'm trying to perform some sort of a ED operation, something like that, right? So I have written a code and I'm going to submit that particular code. Now, what will happen? So it will go through a yarn. So first of all, it will go to a yarn, and yarn is basically a resource manager. Plus it will behave like a job manager, right? Job manager. And then in a bottom layer, I will be having a HDFS. So HDFS. Now this is just a storage layer. This is just what? Storage layer. So my data will be stored here technically into a data node 1, data node 2, data node 3, data node 4. So here my data will be technically stored inside this particular node. So just like we try to store our file into a Windows system, or maybe a Linux system, or maybe into a Mac system, right? So here, and let's suppose if I'm talking about the all different kind of operating system. So into a NTFS file system or FAT file system, it is going to store the data, right? It is going to store the data. So similarly, we have a file system. So where in a distributed mode, it is going to store the data, as simple as that. Now on top of this data, I'm trying to run my code. Yeah, I'm trying to call my code that, okay, try to process this data, because storage is one part. And then when we have to do a processing, so obviously I need a main memory, technically a RAM, and I need a compute, technically a CPU, GPU, or maybe a TPU. Yeah, compute I need. So my storage is completely fine, right? My storage is completely fine. But to process any of this data, I need a resources. Resource means CPU and a RAM. Yes. So I need a resources over here. So what this yarn will do, so inside a yarn, right, inside a yarn, you will be able to find out a multiple major components. So first component is basically resource manager. Resource manager. So basically it's called as RM and this will exist inside a master node. So wherever you are going to configure NameNode, so at that same point, so it will be available. Now what resource manager does, by the way, so as it will be available as, this is just a piece of program, I would say, right? So this service will be available inside a master node. Master node means wherever your NameNode will be, because NameNode is also a service, right? NameNode is also a piece of code. So it will be available inside this master node, my master node, by the way. Yeah. Now what it will do, so it will be having, as it's a master node, so it will be having a global authority on all the resources, because resource will be available in computer number 2, 3, 4, and 5, right? All these are computer technically. And computer means, so every computer will be having a storage, every computer will be having a main memory, every computer will be having what? A CPU, a compute power. Yes, this is what your laptop will be having, right? So your laptop is behaving like a one node. So we have just connected multiple laptop. Now it's become a cluster. Yeah, this kind of a cluster. If I'm going to attach it in this particular fashion. Okay, that's again looks cool, right? Again looks cool. So here, what this resource manager will do, so it will be having a global authority, right? It will be having what? So it will be having basically a global authority. It will be having a global authority to manage resources, basically, right? Across all the cluster. So this is one of the component which exists inside your yarn. Yeah. So I'm talking about basically this middle layer, which is a yarn, and which is actually going to execute your job. So any kind of a code that you are going to submit. And function wise, right? So function wise, what it will do? So it will track. So it will track all the resources across a cluster. Across cluster means what is a resource available in DataNode 1, DataNode 2, DataNode 3, and DataNode 4 as of now, right? As per this particular cluster. So it is going to track all of these resources. Resources wise, when I say resources, so I'm talking about technically a CPU, which is a compute power, and a RAM. Yeah, compute power and a RAM. So this is going to track all of these resources. And then let's suppose if I'm going to submit a job. Job means code. Yeah, job means I'm talking about the code, because technically that is something going to happen. So let's suppose I have written a code in a Spark to perform maybe a EDA operation, as we all understand this EDA operation, right? So the piece of Python code, let's suppose, or Java code I'm going to submit to perform this data processing. Now, so this EDA requires 2 V-core CPU and then maybe a 4 GB of a RAM, right? So this is the requirement of this particular job. Let's suppose I'm going to submit this as a job number 1. Yeah, job number 1 with some job ID. That's completely fine. So let's suppose I'm doing a EDA operation. So for that, I have written a Python code. Yeah, Python code. Now, if I'm going to submit a code, so that code requires, as per the file or as per the data that I have to process, and the like a kind of a code that I have written. So it requires 2 V-core CPU, 2 CPU, and 4 GB of a RAM, right? That is a requirement. Then only this job will be able to finish itself. Now, there must be someone who should provide that like a particular resources, right? Who should provide. So this is where the yarn comes into a picture, and inside yarn, we have what? Inside yarn, we have a component called as resource manager. So which is going to manage the resources. So it is having all the idea that, okay, fine. So in DataNode 1, 2, 3, 4, like we have this kind of a resources. So it is going to create a virtual container, means there is a possibility that resource is available in only one system. There is also a possibility that resource is available in a different system. So it is going to create a virtual container, which is a combination of a multiple systems. And then it is going to allocate that much of resources, which is technically a 2 CPU and 4 GB RAM to that particular job. Right? So it is trying to leverage the whole capability of a cluster. So if resources are not available in one dedicated system, then virtually try to allocate it. Yeah, allocate it, right? And then the second task that it is going to perform, this resource manager is going to perform, that talk to node manager, right? To launch the container. Container means a virtual space which is having 2 CPU and 4 GB of a RAM, which is required for this particular job. So what is this node manager? Because I haven't talked about a node manager. I'm talking about the resource manager, which is basically a global entity, which is a part of my master node. So in each and every data node as a part of this yarn, right? So in a master node, so there will be a resource manager, and yarn basically controls all of this data node as well, and it is going to control it with the help of something called as node manager. So there will be node manager 1, there will be a node manager 2 instance, there will be a node manager 3, and there will be node manager 4, which will be available across all the data node, which is also a part of your yarn service. So yarn service will be available even inside a slave nodes, right? And that is something called as a node manager. Now what node manager does? So node manager is a local entity. So node manager, as its name suggests, so basically node manager, right? So here NM, it will be available per node. So in every node, this node manager will be available. Like I have written node manager 1, node manager 2, node manager 3, node manager 4. What it does, and it is also a part of your yarn service. So yarn is a service on a high level. Inside that there is a resource manager, which is a global program, you can say. There is a node manager, which is a local program, you can say, right? So what it does, so basically in each node, right, in each node, it try to monitor a resource uses, because see, it is trying to maintain the resource manager, right? At the end of the day, it needs someone, so which will be able to tell on a node level that, okay, what is the availability, what is not. So you can say that this is a lead, which is leading a team, and this is a manager, so which is having a multiple leads, and like it is managing a multiple leads, and lead is trying to manage its own resources. Simple, right? Just like a company structure. So here it is going to tackle it is going to track the resource uses. It is going to track a health, that which one is going down, which one is up, and then a container status. Container means, so whenever you are going to submit a job, so one virtual container will be spawned, one virtual container will be launched, and then someone is supposed to manage, someone is supposed to monitor that container. So if that container is going to fail, it simply means that my job is failing. And if job is failing, so I have to talk to my resource manager. I should say that okay, so this has failed. Now try to understand, or try to maybe launch it again, or maybe do something, right? Do something. So this is something called as node manager. Now the third component you will be able to find out inside this yarn is called as application master. Application master. So it's called as AM. Yeah, application master. So per application, it will be created. Now what is the meaning of this? So see, resource manager means global. So it will be having access of all the cluster. Node manager means inside one particular node. So data node 1, 2, 3, 4, 5, 6, and so on. There will be a node manager. So node manager 1 in our cases. So technically there will be node manager 1, there will be a node manager 2, there will be a node manager 3, and there will be a node manager 4 on a node level. Now inside that node, so we are trying to do what? So we are trying to write, or we are trying to create a job, means we are trying to execute a program, right? We are trying to execute a code. So over here, there will be application manager comes into a picture. So let's suppose I have submitted one job, one application manager, or like a multiple job, multiple application manager. So on an application label, right? So basically it will be spawned, or it will be activated once per application or job. Simple, try to understand it in a term of job, right? So basically it is going to execute an actual job, it is going to track an actual job, and it is going to monitor, and if it is going to fail, so it is going to report back that okay, fine, so this job has basically failed. So based on the application master, which has been created per application wise, means technically an ID which will be created per application wise. So if it is going to fail, so that application ID will be submitted, and it will be said that okay, fine, this application has failed technically. Yeah, this application has failed. So what application master does, so it will be activated, means application ID, it will be allocated per job, whatever job. For example, I have submitted EDA job number 1. So application ID will be submitted. Again, second EDA. So job number 2, that application master 2 will be activated, and then it is going to request request. So it will try to request a container, because to run the job, right, to run a job, I need a resource. I already talked about it, right? To run a job, I need a resources, 2 CPU, 4 GB RAM, for example. Yes. So it is going to request a container. Container from whom? From my resource manager, the very first entity. This is the global entity which is responsible for locating the resources, right? And track for locally tracking the resources, there will be a node manager, right? There will be a node manager. So this is going to request a container from a resource manager. And last but not the least, so it is going to monitor the task, not all the tasks, monitor the task, the respective one for which it has been created, and it will always try to retry if task is going to fail. And the fourth container, fourth is what? So fourth component is what? A container. I think I have already talked about the container. So container is nothing but a logical bundle of a CPU and memory. Simple. A logical bundle of CPU plus memory. Yes. So whenever you are going to run some sort of a job, so obviously that is going to run inside the container, means inside the real resources. As simple as that. Yes. As simple as that. So here, so if I have to talk about the complete flow, so let's suppose I have written a EDA code, EDA.python code, right? EDA.python code. And I have to process a data which is available inside my HDFS, fine, which is available inside my HDFS. So it will go to what? So it will go to Yarn. Yeah, it will go to Yarn, yet another resource negotiator. Now, so Yarn, what Yarn will do? So Yarn will be having an understanding that, okay, fine. So where data is available, what is the volume of the data, what is the block of the data? It will be aware about each and everything from a name node, obviously, because it's a part of a master node itself, or master architecture itself. So now, so if I'm going to submit this particular job and I'm going to name it as a job number 1, fine. So I'm going to name it as a job number 1. So let's suppose if I'm going to submit a job number 1 in this Python file, and here I have written a code into Spark. Yeah, here I have written code into a Spark. So I'm using a Spark framework to write a code basically to process the entire data. So it will go to Yarn, and every job requires a resources. So CPU and a memory at the end of the day. So based on the data set that you have to process and based on the task that you have written. Okay. So it is going to estimate each and everything. So here your resource manager will come into picture. So from a Yarn itself, your resource manager RM will come into a picture. Now RM is already connected with a multiple, right? So RM is already connected with multiple node manager, which is nothing but a part of a node manager. Yeah. So 1, 2, 3, 4, which is a part of your data node. Physical, system wise, if I'm going to talk about. So RM is already connected with the multiple node manager, right? So it will ask a node manager that, okay, so someone has submitted this particular job, and to execute this particular job, so I need 2 CPU, and basically I need a 4 GB of a RAM. So this is the requirement. Now who is going to give? So it will say that, okay, I'll give. It will say that I will give. Fine. It is going to say that I will give. Okay. So if it is not having a 4 GB of RAM, and it is not having a 2 CPUs, so maybe it is going to provide 1 CPU and then 2 GB RAM. Fine. And it is going to provide 1 CPU and 2 GB of a RAM, right? So it is going to combine these two, and it is going to basically call that as a container. And to track this container, so here there will be a application master, AM will be created, so that it will be able to track this particular application, which I am calling technically as a job number 1. As simple as that. Yeah. So this is the virtual container it is going to create, which will be a shared resources between a multiple systems, technically a multiple laptop, you can say, and it is going to execute your job, and it is going to again respond back to a Yarn saying that, okay, fine. So I'm able to do my task. I'm able to do my work. So this is how this entire ecosystem works, guys. In terms of a Yarn, this is how Yarn is going to maintain the resources. I'm going to show you each and everything, even in my practical example, right? So I'm going to show you that where you will be able to find out all of these detail, but hope all of you are able to understand this entire Hadoop architecture in a very detailed manner. If you have any kind of a question, so don't forget to ping me. I'm here to help you out. I'm here to make you understand. If you're not able to understand any of this component over here, or if you have any kind of a confusion, don't worry. I'm here for you. Till then, take care everyone. See you again in my upcoming lecture. This lecture is lengthy, but just go through it once. You will be amazed and you will find it amazing. Literally very amazing. So with that, thank you so much everyone. Take care.